So we first start with Marina from Fuelium, and she'll tell us about fit-to-purpose batteries for responsible portable electronics. Then we hear from Papierfabrik, Luisenthal, and we'll learn about large-scale fabrication of low-haze transparent metal mesh foils. And finally, we hear about sort of a liquid crystal system for AR, VR, XR applications. So I think we are ready to start with the session. And Marina, when you're ready, please join me on the stage. Hello. So you can just change the slides.
I think that
you want to do that? No?
Yeah.
Perfect.
Okay. Hello to everyone, and thank you so much for your interest in this talk. As introduced, I'm Marina Navarro, and today I'm here representing not only Fuelium, but also our research group, which is called Co-Designed Energy and Systems. During this presentation, I am going to explain the research in the area of portable power sources that we have been carried out first at the Microelectronics Institute of Barcelona and currently on the Basque Center for Materials in Bilbao. This work has led to two spin-off companies, one of them Fuelium. As I said, currently we are based in the Basque Country, and our research is devoted to develop portable energy storage systems, eco-designed considering the relationships between the biophysical resources that they use and the social outcome that they generate. So here is the outline of the presentation for today. First, I will start with the motivation of our research. Then I will introduce a little bit the philosophy that we are developing in parallel to our experimental research. I will introduce some examples of these technologies that we are developing, including the technology that Fuelium is currently commercializing. And finally, I would like to end introducing this concept of bounded batteries. So first of all, the motivation. As you all know, we are currently living a society digitalization era, and digital technologies have already shown many benefits to society. That's why we are here today. But this digitalization era is going to it's forecasted to not stop growing. In the future, with this Internet of Things concept, we are going to be surrounded by trillions of sensor nodes. But even nowadays, we are already surrounded by a huge quantity of portable electronic devices that need portable batteries. And this is where it lies the motivation of our research, because more than 200 kilotons of portable batteries are sold in Europe every year. And as you all know, during the end of life of these batteries, they need special collection routes and recycling. But nowadays, the majority of these batteries end up in landfills, poisoning the ecosystem and contributing immensely to the environmental degradation. In those cases in which the batteries are in fact recovered for recycling, we find that their complex design, together with the hardness of the materials that they are made of, make this recycling process really energy intense, for which, moreover, there is a completely lack of local management. So these are the problems generated at the end of life of these batteries, but a close look into their life cycle reveals that severe environmental consequences are generated from the first stages. So from the fabrication, which is based on scarce non-renewable materials, and it's done in centralized facilities, consuming energy from finite resources. And this centralized fabrication causes that the batteries need to travel thousands of kilometers to the point in which they are going to be used. And then during the use phase, we find that their generic design, regardless of the application, makes that sometimes the lifetime of the battery is not coupled with the application duration, causing that in some cases the batteries are disposed of even without being completely depleted. So in this scenario, from ETSI and Fuelium, what we propose is to completely redefine the battery paradigm. And from the use stage, we want to reshape the whole battery life cycle. How to do that? Well, we start by analyzing the requirements